Hello students and welcome to today's session. My name is Boniface Waweru from the School of Public Health, and I'm here to present a session, a very important session on toxicological risk assessment. The title of the unit is BPH 3201, Environmental Toxicology. So, what are you expected to learn by the end of this lesson? The first thing, as students, we are supposed to be able to understand common toxic agents that are present in our environment and in our Kenyan situation. The second expectation is for the students to understand the application of the dose-response relationship. And finally, to identify and discuss the toxicological risk assessment process. And I will go on the first slide. We need to understand the meaning of the term toxicology. Toxicology is a scientific discipline that helps us to study and understand the three agents that cause adverse health effects and also damage our environment. They are chemical, physical, and biological in nature. And much as we have biological agents here, which may include bacteria and viruses, I want to say that a majority of these toxic agents that are present in the environment are chemical in nature. And I think as human beings, we need to take responsibility, because it is due to our actions that over 70% of these chemicals are present in the environment. And the most suspect activity is discharge from industrial areas, and we are going to move on and see how serious industrial effluent is. In toxicology, we say that no chemical agent is entirely safe and no chemical agent is entirely harmful. Paracelsus is known to be one of the fathers of toxicology, and we still remember him today because of his most popular statement, where he said that all substances are poisons. There is none that is not a poison. It is only the dose that differentiates between a poison and a remedy. The most important thing to note here is the dose. That, and I can demonstrate this by using an example. When you go to the hospital, say you've come down with malaria, the doctor gives you a measured dose in form of a prescription that is just enough to counter the attack by the plasmodium in the body. But if this dose is increased, then it stops being a remedy and becomes a very serious poison. So the dose is a very important factor. What are the common agents, toxic agents that are present in our Kenyan setting? One of the biggest classification of these agents is the heavy metals. And these include mercury, lead, cadmium, chromium, and others. Lead poisoning in Kenya has taken place in a number of areas, and the most serious event took place in Mombasa, and after investigation, it was found out that this heavy metal lead was released from a neighboring industry that processes or used to process used car batteries. Chromium, on the other hand, has been known to be used widely in leather processing industries, and if these industries discharge their waste into the environment, that is the water bodies, without duly treating the waste, then it means that these heavy metals will be present in the environment. We are going to see some of the serious health effects that are caused by these heavy metals. The other important classification is the solvents, and here we have alcohol as well as benzene. And alcohol is a serious public health problem, mainly in two ways. The first way is when a pregnant woman depends on alcohol regularly, she unknowingly introduces very high concentration of alcohol into the fetus blood. And this fetus may likely be born with a condition known as fetal alcohol syndrome. The other way in which alcohol is a serious public health problem is when most alcoholic drinks out there are laced with ethanol, which is adulterated. How do you adulterate ethanol? You adulterate ethanol by adding readily available cheap methanol, and you sell that to unsuspecting clients because both liquids are colorless. Benzene has also been known to be a serious public health toxicant, and continued exposure to benzene has been known to cause leukemia, and that is blood cancer. The other important classification here is the pesticides. We have different types of pesticides in use in Kenya, the most important ones being organophosphates and also carbamates and polychlorinated biphenyls, commonly known as PCBs. What is the problem of pesticides? Are they safe? What has been documented is that continued use, and that's where we are as a country because of the continued or increased interest in horticultural farming, is that pesticide residues have been found in water bodies, that is the lakes and the rivers. And of course now we can say that there is a serious impact on aquatic life, most importantly on fish. Then lastly, you have dioxins. Dioxins are mostly found in industries that deal with chlorine, and sometimes they are released into the atmosphere as a result of the combustion process, especially when we burn compounds that contain chlorine. This could be plastics or PVCs and others. The problem with dioxins is that it's a serious environmental pollutant. It has been known to exist in the environment for over 100 years, and that's why we are calling it a persistent organic pollutant. Now, there's a serious problem in Kenya, a serious toxicological problem in Kenya, and I just want us to look at a few issues that have taken place in the last few months or years. We can remember that a few years ago, there was a serious case of lead poisoning in Mombasa, and most children in that settlement in Mombasa were found to have high blood lead levels. The other thing that happened in that area is that most mothers who were pregnant resulted in stillbirths, and after an epidemiological study, it was realized that the major source of this lead was a neighboring factory that processed used car batteries. We've also had cases of mercury poisoning in Western Kenya among gold miners, and I know they are continuing the studies to continue, bring out the risk factors associated with mercury poisoning. We've also seen documentaries in our televisions documenting very high levels of aflatoxin in our maize flour, as well as some products or brands of peanut butter. This is a serious public health problem, and these are just reasons as to why a toxicological risk assessment could be offer solutions to these problems that we are talking about. We've also seen cases of meat laced with preservatives, very high concentrations of these preservatives, and also cases of methanol poisoning some time back in Kenya, where people consumed unknowingly methanol-laced alcohol, and most of them ended up dying. So we are saying that one of these solutions to these problems, and what are the problems? The problems are the introduction of these chemicals into the environment. We are saying that one of the solutions to at least eliminate, or where not, if it's not possible, to reduce the concentrations of these chemicals in the environment is by conducting a risk assessment. So a risk assessment is a very important component of risk analysis. The other two components being risk management and risk communication. A risk assessment is a scientific process which involves a collection of information, important information on the concentrations of chemicals in the environment, and the doses or the concentrations, the different concentrations at which they occur at different areas in the environment, be it at the source or at the ultimate areas of the environment, especially when they're being transferred through freshwater bodies such as rivers. Once you get this information, this process also wants to understand what are the main or the major sources of what are the major sources of these chemicals? Where do they originate from in the environment? And we had seen and said that over 70% of these chemicals that lie in the environment can be traced back to industries. So once we get this information, we also need to evaluate what will be the potential environmental and health effects after exposure to these chemicals. So we had said that if it's an event of mercury poisoning, then the ultimate health effect we expect from that exposure is neurological disorders. If it's a case of lead poisoning, then the ultimate health effect from that exposure is reduced IQ among children or stillbirths in pregnant mothers. Then at the end of the day, we want to measure these exposures and finally have this information, both quantitative and qualitative information, to help the decision makers, the risk managers, public health practitioners, to help them in coming up with solutions or interventions that can help reduce or eliminate these chemicals from the environment. Risk assessment is a four-stage process, starting from hazard identification, dose response assessment, exposure assessment, and finally, risk characterization. Let us look at the first stage or step, which is hazard identification. Basically, what we need to do here is to identify any toxicant that may be present in the environment and that has a potential of causing health hazards. So how is this done? The major source of the information regarding these toxicants is normally found from laboratory tests. Scientists conduct rigorous studies on chemicals using laboratory animals such as mice, and results from these experiments can help us identify toxicants that could lie in the environment. We also can rely on epidemiological studies, that like the example I've given earlier, I gave earlier. And as well, we can conduct field investigations also and collect samples, be it they water, air, soil samples, to analyze them in the lab and document the toxicants available in the environment. Then, under hazard identification, the second process or the second step is to describe the potential resultant health effects due to toxicity of these chemicals. If we are conducting a risk assessment on alcohol or ethanol, then we would want to imagine that one of the resultant health effects will be hepatotoxicity or damage to the liver. If we are conducting a risk assessment on mercury, then neurotoxicity will be a potential health effect. And finally, we need to evaluate conditions under which these forms of toxicity can be expressed in exposed humans. And when we talk about hazard identification, then the aspect of risk is very crucial here. And risk in the process of conducting a risk assessment is defined as a product of both exposure and the available hazards. We've said that the most crucial sources of information or data to help us in conducting a hazard identification are animal toxicity studies from experiments in the lab. We can also have data from human studies, epidemiological studies, or randomized control clinical trials when we're trying for new drugs, as well as in vitro studies and data from non-food sources such as occupational or accidental exposures. Then the second step in the risk assessment process is dose response assessment. One of the other things that Paracelsus established, besides this famous statement on the dose, he established a dose-response relationship. And a dose-response relationship helps us to understand the expected response or the health effect that we expect at different doses of a certain chemical. And this information is usually derived from animal studies in the laboratory. And when we do this, there are three terminologies that come up which help us interpret the relationship between chemicals at different doses and the expected response. The first one is lethal dose 50, commonly known as LD50. And lethal dose 50 is usually the amount or the concentration or the dose of the chemical that is just enough to cause death in 50% or half of the animals under the test. So we are saying, if I can give an example, if we're in the lab and we want to establish the lethal dose 50 of, say, mercury, all we need is a population of, say, laboratory rats, say 10 rats, for instance, and then we introduce this chemical into these rats and gradually increase the dose of this chemical until such a point where half of these 10 rats will die. So we are talking about 50% death. So we take note of that particular concentration. And dose in this case is usually measured in milligrams per kilograms. The other terminology is no observed adverse effect level. This is usually the lowest level of the chemical, or the lowest concentration of the chemical in which there is no obvious response, meaning that we could be exposed to different chemicals at different concentrations, but at those concentrations where no observable health effect is observed, that concentration is what we're calling the no observed adverse effect level. Then lastly, we have the lowest observed adverse effect level. This is the lowest concentration of a chemical which or when response or health effects start manifesting. We can see these three in a graphical representation where after a series of laboratory experiments in the lab with the lab animals, we can come up with this kind of graph. Here you see this point here denotes the lethal dose 50. And we are saying this because if you look on the y-axis, this is the response in percent. Meaning, if death is the response here, then we expect 50% of these rats to die at a certain concentration of the dose. The x-axis denotes the dose. So in this example, we can see that at about 22.5 milligrams per kilo of this chemical is just enough to kill 50% of the rats. That's the LD50. And of course, we can see the NOAL here and also the LOAL here. This is the concentration, the lowest concentration at which response is observed. So the third step here is measuring the exposure, because the dose and the exposure are very important components in a toxicological risk assessment. We cannot conduct a successful risk assessment before we determine the dose of these chemicals and the exposure to these chemicals. And under exposure, we want to mainly look at the main sources of these chemicals. If it's industry, we need to have documented evidence to show that this effluent that comes from industry X could be the cause of this concentration of this chemical in this water body. Then we also need to look at the exposure pathways. So how does the human being living in that environment take up these chemicals that are available in the environment? And here we are looking at different pathways. The individual could inhale the chemicals if they are present in air. The individual could also ingest the chemical if they are present in the soil. And he could also get them through contact and also other pathways. Then the aspect of exposure here is very important. And we are saying that even for an extremely hazardous chemical, the risk of an adverse outcome is unlikely if the exposure is near zero. And you see the converse of that statement is true, that a moderately toxic substance could present substantial risk if it is highly, the population under exposed to that chemical is highly exposed. Then we need to understand how we measure concentrations. And the most obvious and correct way of measuring concentration of these chemicals in the environment is to collect samples. If we suspect that Lake Y is seriously polluted from industrial activity, all we need to do is collect water samples from that water body at different points. But sometimes these samples do not yield any result in a laboratory. And at this point, we are scientifically allowed to, of course, come up with mathematical models that can help us estimate the concentrations of these chemicals in the environment. Finally, The last step is characterizing the risk. At this point, we now have information regarding the source of these chemicals, the routes of exposure to these chemicals, and the expected resultant health effect in the human being. All we need to do is summarize that information and not forgetting the information we got from the lab. The one that tells us that in this water body, this is the dose of this chemical, these are the concentration of aflatoxin in this maize flour, this is the concentration of lead in air, and such examples, and then use these measurements and compare them against the standard guidelines. The example I gave for maize flour, we realized that there was a product, a particular maize flour product, that contained over 50 parts per billion of aflatoxin. That was way higher than the recommended WHO level for aflatoxin in maize, or maize flour, which is about 5 parts per billion. Then what we need to do with this information is to provide it to the decision makers, those who sit at positions where they can influence policy, and also those who sit at positions where they can implement intervention measures. We need people to use this information to come up with interventions that can help reverse the damage that has already been caused by these chemicals. And finally, in conclusion, we are saying that we need a balance between risks and benefits. Why are we saying this? We are saying this with the knowledge that if over 70% of these chemicals come from industries, why can't we just close down the industries? But you realize that this is not possible, because as human beings, we need these products from these industries. We need good shoes from a leather industry. We need sugar on our tables. And we need these other products that we use on a daily basis. However, we are saying that it's okay for the industries to operate, but let us not allow them to operate in the event that we know or we have evidence that they are discharging these chemicals into the environment. I think that's very important. And we're also saying that toxicological risk assessment can provide this much needed solution to increasing concerns to toxic agents. I mean, there has been growing concerns. People saying that the reason we have high number of cases of cancer is because we've polluted our environment. There are so many chemicals in our waters, soil, etc. If we have formal ways of conducting toxicological risk assessment, supported ways or supported risk assessment, then this could be the beginning of solutions to these problems. And finally, law enforcement is very key in eliminating or at least reducing these concentrations in the environment. Of course, accompanied with multi-sectoral collaborations. We have departments of environment out there. We have departments of public health in the ministry, and other departments such as water and regulatory authorities. If they come together and go back to the drawing table, formulate plans that are implementable, plans that will be followed by law enforcement, then I think we can gradually start moving from the situation we are already in. So that marks the end of this session. Thank you for your participation. In case there are questions, we will be able to address them through the online platforms. And of course, I'm sure you will get the information you need. Thank you.
These televised lectures supplement our robust online learning going on our MKU online platform. You can view more on our televised lectures via our online platform. We are in a digital era, and Mount Kenya University knows this. The following are the steps to follow so as to complete your online application. Download the application form from the website www.mku.ac.ke. Attach copies of your academic certificates and ID. Pay the application fees via M-Pesa pay bill number 270988. Your ID is the account number. 2,000 shillings is the charge for a postgraduate. You can also deposit in the bank accounts provided on the website. Then email all the above to apply@mku.ac.ke.